Okay, so a completely different talk after what Oliver talked about, and hopefully this will not jar too much from the last talk, because this is far more practical in some ways and structured. I'm going to be far more, I think it's the word pragmatic, I think, and tell you what you should be doing or what you should not be doing. But we'll talk a little bit about some evolution stuff as well. So software deployment and getting our software from our code on a single machine or group of machines into live in some sort of sensible manner. Wikipedia is of course never ever wrong and is a font of all knowledge. So software deployment is all of the activities that make a software system available for use, and that's a fairly good description of what we're talking about here. It is more than just dropping some code on the server. Deployment is a little bit more complicated than that. There's a lot more involved. And this talk is deployment in a traditional IT environment. So when I say traditional IT environment, I mean things like this. Now you have probably seen that logo on the left before. Microsoft Windows, you've probably even heard of Microsoft Windows Server. Does anyone here deploy to Microsoft Windows? Okay, wow, 3 people. That is way more than I expected. Are you responsible for the security of said Microsoft Windows servers? Oh, you did? Okay, in the current, I still deploy to Windows servers. What about this symbol? Does anyone recognize this symbol? Right. That's IBM I, which is the new name for IBM AS400, which came out in the early to mid 80s, is still current, still very expensive, and is in more installations than I would have believed possible. It's a remarkably weird system, and people have got lots of business data on there that they would like to expose, to give out to the world. So I write APIs that talk to those legacy systems, and we have to deploy to some remarkably weird boxes. So what's not in this talk? Cloud deployments, provisioning of servers, continuous delivery, chat-ups. These are all related to deployment that happened in this century, hence they are not applicable to a typical traditional IT environment. So we're not going to talk about those. Cloud deployments are really interesting and are clearly where we'll be going in the future. But you will have to wait for someone else's talk on that, whereas we're not going to talk about it here. And to be honest, I am not remotely interested in servers. They are just not my thing at all. I couldn't care less about servers. They are horrible things that someone else deals with. So we're clearly not going to talk about them because I'm uninformed and don't care that I'm uninformed. We are going to talk about some fundamentals though, because the deployment bit is at the end of a process. And if you are not doing your practices, your development practices, the way you are working correctly, it can be impossible to deploy in a repeatable manner. And if you can't deploy in a repeatable manner, then you will have problems on live. You will have lots of problems on live. You will sooner or later lose data. You will deploy things that are wrong. You will make mistakes that result in business loss. And that is bad. At the worst case, it is very expensive and businesses will go out of business. You will lose our business completely. At the best case, we are horrendously embarrassed. And we don't want either of those cases because we're British. Development processes, code organization. You need to isolate your work. You cannot reliably deploy anything to a live server if your work is not isolated. So that what you are actually developing, it doesn't accidentally end up in customers' hands too early. We do that by working on branches. I'm going to make a huge assumption here that everyone is using version control. Do not raise your hand if you're not, because it's just too embarrassing, isn't it? When I first started talking about deployment, a surprisingly number of people had not heard of version control, let alone used it. So I think we're a little bit further than that, but people are not using version control maybe as well as they want to. And the key thing about version control, the key thing that you can do is that you can always have a way to bug fix what is on live before you put it back on live. That's what branches give you. So you can organize your branches in many ways. This is one way to do it. Feature branches system. You'll see this sometimes described as GitHub Flow or something like that. I don't like the phrase GitHub Flow because it's too close to Git Flow, and two different methodologies with basically the same name is a problem. So we will call this feature branches. And the idea here is that any new work always happens on a branch, and master is always live. There is never a situation where anything on master is not live, and there's never a situation where you deploy or merge directly to master without going live at the same time. So here we've got a couple of new bits of work. Each one of our commits to master is a tag. We deploy off tags, we branch off, do some work, and then we merge it back to master when it goes live. Quite an easy system to work with. It works, in my experience at least, fairly well with smaller development teams. Larger development teams, you probably need a little bit more structure. Which brings you to Git Flow. Git Flow is more complicated. There are lots of documentation on Git Flow. It makes a lot of sense with slightly larger teams. It makes a lot of sense if you want to do testing in a fairly sane, automated manner. It certainly is slightly easier to do so. I would recommend you read up on Git Flow if you're not using it and decide why you're not using it. There are perfectly valid reasons for not using it because it is more complicated. It may not fit the way you are thinking, but it has a lot of useful properties in it. Key thing about Git Flow is that we have two branches that are active at any given point in time. So we have the master branch, which represents what's on live, and we have the develop branch, which is where we do our work. We test on develop, we integrate new features together on develop, we can do all our integration testing, etc. on develop before it goes anywhere near the live system. But when we go for deployment to live, we always create a release branch. So we have a branch where we can get sign-off, we can do all our testing, we can put it on an environment that is identical to live before it goes live. And when we are happy with it, we deploy to live and we put it back into develop because there's always one fix or another in that branch every single time. So that's the key difference about Git Flow, is that whole concept of release branch, which does make testing that much easier, which brings me nicely onto testing. Automatic testing is a really, really good thing to be doing for any code that is going to go live. If you can do this, it is worth spending the time doing. Lots of different types of testings you can do, things you should be looking for: unit testing, functional testing. You're going to need to do some sort of acceptance testing. They get a bit harder to automate. It depends on how good your systems are. If you can automate them, that is lovely. At some point, you are going to need to have a customer involved to actually sign things off. Customers don't tend to trust automated testing so much. They tend to like to see it happening themselves. I don't know, it's a comfort blanket thing, from what I can tell. So you need some form of testing, make sure you are doing that. What else do we care about? Databases. I said that deployment is not just the code, there's also databases, there's also content in your databases. Changes to your schema is in your databases. You need to manage that as well. The worst thing you can do is log onto your live database with PHPMyAdmin and do anything, pretty much. You're going to end up in a world of hurt. So the system is called migrations. You have an automated and repeatable way to make changes to your database as well. It is as important as changes to your code base. Migrations are fairly simple. We just store our schema changes in individual files. They call them Delta files, and they have up and down functionality. So we have the idea that we can roll back as well as roll forward. We can repeat these schema changes. So we can do dry runs. We can test with our live database on a test system and find out what screws up before we do it on live. It is amazing how frequently a database schema change works on a dev's machine and does not work on the staging environment. It's unbelievably frequent. I see it in the Slim Slack channel at least 3 times a month, that someone is confused that their development environment has deviated from live. This is what happens. That's the way the world works. And being able to do repeatable tests of things means your chances of messing up a deployment go down considerably. There's loads of different tools you can use for migrations, like there's more than one choice for handling your version control. I don't particularly care which one you use. It doesn't really matter to me. Pick one that actually works the same way as your brain. That helps a lot in this sort of stuff. Other thing related to deployment and environments in general is your configuration data will be different. Specifically, we call this context awareness. Every instance of your code will have different configuration because you're probably talking to different databases. At least I hope none of you are developing directly against your live database. Highly unlikely. At least you won't do it twice once you've made a mistake. So we need our source code to have some sort of configuration. Again, there are a variety of ways of doing it. The two most common ones is to use environment variables or to use a local configuration file. There's something called the 12-factor system, which Heroku came up with for how you do easy deployments and easy cloud work. 12factor.net/config is quite a good read on how to use environment variables for configuration. It's quite a nice way of doing things. Local configuration file works just as well. I've got systems that have deployed both of these ways, and it's fine. The key thing is that you have thought about it and are not surprised. In fact, a lot of deployment is all about not being surprised. Being surprised when things go live is never a good sign. And that's it. That's all the fundamentals we need to care about. We need to care about our code is isolated. We need to care that we are keeping track of database schema changes, and we need to be aware of configuration and context for each of our installations of our source code. Which brings us nicely onto deployment. Now we're going to talk a little bit about the evolution of deployment itself. So here's where I tie nicely into the previous talk. So it makes it feel like there's a nice structure to this evening. So where did we start with deployment? Anyone? FTP. I couldn't bear to write FTP without putting an S in front of it. Sorry. But yes, at the very beginning, we started with manual deployment, where we simply copied the files to the right place. Using Dreamweaver? Probably. Pretty sure none of you are doing that nowadays. Again, do not raise your hand if you're still using Dreamweaver to copy files to a server. FTP or SFTP, rsync. Fairly recently, I caught one of my clients using remote desktop to copy and paste files over to their live server. This is very much a manual deployment, and manual deployments have a number of problems. First and foremost, it's a remarkably slow way to get something done because you have to sit there and do it yourself. And there's far better things you could do with your time than watching an FTP bar go across the screen. Far more important, you end up with inconsistencies between each deployment. The chances of you doing the same thing the same way twice is relatively small, and manual deployments are remarkably boring things to do, so your chances of screwing them up are that much higher, which is called a failure in production. It's problematic to get it right. And finally, we get this problem of no records. Who deployed what? When did they deploy it? Where did they deploy it to? You have no records of any of this thing happening. And this comes back a little bit to that traditional IT environment thing. Traditional IT environments tend to be more enterprisey, more formal, and they tend to like to know when things change. So that comes up there. When you've got ChatOps and you've got the new cloud deployment stuff and continuous deployment and stuff like that, you sort of get automated records for you. So that's quite helpful. But knowing when something was deployed is really, really helpful when something goes wrong on live. And what is on live is also really, really helpful. Going back to this more than just code. Not only is there the database, you've got some other things you need to think about. The file permissions. If you're going to drop files onto a server, they need to be readable by the user that is running the web server. That could be quite easy. It's not too bad on the Unix-like operating systems. It's mostly consistent on the Windows boxes. And it can be all over the place sometimes when you're on a mainframe computer or a mini computer like IBM I. You need to be aware of it. You can't just assume that when you're copying a file over from here to here, that the permissions will stay the same. It doesn't always work like that. User uploaded files. If you've got a system that allows users to upload files, where do they get stored? The amount of systems that store it in the same directory as your web code is unbelievable. And then you go and do a deploy and wipe them all out. That is not very clever. People don't think about this. Caching as well. It's fairly common to cache configuration files, and they need to be cleared if you're going to do a live. If you have an ORM type system, they're the most common ones, you're probably going to need to prime that cache, because it can be remarkably slow to get the first few database queries out of the system if it is not a particularly efficient database design. So you might need to think about actually priming the cache and getting, say, all your twig files need to be cached up into the PHP side, for instance. You might need to do that if your site is, has enough scale and is that busy. And again, keeping records. You do need to know what you've deployed and when you have deployed it, so you can invoice for it. There's probably some other reasons, but being paid is number one on my list. Can you tell I'm self-employed? This thing is important to me. So keeping records is important. You do need to do it. Which brings me back to people and not machines. If you can get people out of the boring stuff, that is always a good thing. So people are really, really good at creative judgment. That's why they make good developers. Machines are really good at doing the same thing over and over again, which is why when you get a bug, that bug never goes away on its own. There's a reason for that. Machines do the same thing. They do exactly what you tell them over and over again. And this is one of those situations where we benefit from that. If we write an automated deployment system that the machine does, it will do the same thing next time. So if we got it right the first time, we'll get it right the second time, which is more than will happen if you use a manual deployment process. Other benefits do we get from automation? We can defer deployments. Going back in history a little bit, some of you might be too young for this, but VAT used to be 17.5%. VAT used to be 15% as well, but I'm certain there's only me and Stuart that remember that. When we went from 17.5% to 20%, the Chancellor of the Exchequer, in his wisdom, decided it would happen at midnight on January the 1st. That would be the time it would happen. That was when I had to make sure that I deployed my update to my source code, because the systems I was using at the time didn't have the concept of deferment of anything. We couldn't have a change to the VAT rate in the future. It had to happen at the right time. So I had a choice. I could either deploy at midnight on the 1st of January, or I could automate my deployment and be drinking and celebrating the new year on the 1st of January. This was when I first learned how to do automated deployments. What can you do? Deferred deployments are really, really helpful. You can choose when something goes live independent of when you're available to do it. You can do self-service deployments. Why should I have to do deployment at all when my client is the one who has to sign it off and my client is the one who's going to pay me and my client is the one who's responsible? Why can't they press a button to deploy? That'd be nice. I could tie it into my invoicing system. They deploy, they get an invoice. We could do this, automation. We could automatically trigger deployments. We call this continuous deployment. If I tag my master branch and push it to GitHub, why can't a system deploy it immediately for me? Why should I have to go and press another button? We can automate these things. We can run smoke tests. We can do automatic rollbacks when things screw up because we found them in the smoke tests. We can do lots more things with automation than we can do if we're manually doing this stuff. Because when we're manually doing it, we're bored and can't be bothered. So our scripts will provide consistency. They give us a platform for doing this additional stuff. We don't have to wait for other people to get stuff done, and it's much less hassle. Right, so if we're going to do deployments, if we're going to automate them, the first thing we have to do is write down what we want to do. This is the same as any basic project management, any basic development task. It is no different. You need to know what you're about to do before you try and do it. It's remarkable how much trouble you get into if you start doing something before having thought about it. So we call this a deployment checklist. Here's some things that end up on your deployment checklist. You're going to have to copy your files and folders over to the deployments, over to the live server. We're going to have to do our database schema changes. We're going to have to do content updates if they're part of our web application. Our configuration updates might be in place. We're changing from one SNT provider to another. File permissions, clear caches, etc. Whatever they are, write them down. Know what you need to do a valid and complete deployment. Once you've written down what you need to do, you can then turn it into an automated system. There's a number of ways you can do that. Simple script, Makelike tool, or a specialist tool. We all start with a simple script, unless we've got so much time that we can jump straight into one of the more advanced ones, but nearly everyone starts with a nice simple script. Makes life easier. We're just automating what we're already doing, so it's a nice, easy thing to do. Bash, PowerShell, PHP, if that's your language of choice. You might write it straight into PHP. It's fairly good for this sort of stuff. Not ideal, but fairly good. Usually run it on the server. So if you have some sort of deployment script, 9 times out of 10, you will log into the server and then run the deployment script, and it will update in place or however you're going to do it on live. Works well. Obviously, some negatives. Anyone think of any negatives to doing this way? Someone must have an idea. Connection dies halfway through, that'd be bad. Same thing. Multiple servers have to be done in order, and you might forget one of them. That'd be fun. 4 servers, and you only update 3 of them. You know it'll be the wrong one. The one that your client hits first is one you forgot. You also have to give whoever's doing it access to the live server. So I'm trustworthy. You can give me access to your live server. Nearly always. Do you want to give everyone access to your live server so you can do a deploy? Like when you're on holiday, do you then want your junior dev to have access to the live server so they can do deploy when you're at the office? Maybe, maybe not. Maybe you're more trustworthy, have more trust in them than I do. I don't know. So we move on from that into Makelike tools. I call it Makelike because only people like me remember what Make is. We're all using some other tool now, but there's loads of choices that are all basically the same thing. But it's an abstracted script, which means it's far easier to make it cross-platform. So you tend to see make, thing, ant, rake, whatever it might be. They're fairly easy to make cross-platform, and they're more likely to push to the server. So you tend to have some sort of deployment credentials involved at this point. You tend to start seeing these hooking into things like GitHub as well, or into your CI system, because it's relatively easy to do at this stage. Tends to be easier if you've only got one server or a couple of servers to deal with. When you start needing more than 1 or 2 servers, then start thinking about the more specialist tools, because they're designed to solve this problem far better. Again, there's lots of choices. Fabric, Capistrano, Ansible, Chef, Puppet, Salt, slightly different layers of abstraction between those two. If you want to do it as a service, there's obviously a software as a service you can buy that will handle deployments for you. It's called DeployBot. In fact, there's probably others, but DeployBot is one I've seen and I've used it. Way more likely to automate this stuff. If you're at the point where you're using specialized tools, you're going to be automating it. Life will be much, much better. Go for it. Definitely where you want to end up if you can. Very, very easy. Well, it's not too difficult. It's much, much better as a system to have a nice automated deployment system. So therefore I should talk about the negatives, or the challenges. Challenges is a far better word than negatives, isn't it? And there's always challenges in anything we do. There are a few technical challenges, platform challenges, permissions challenges, mostly because of IBM or Microsoft. That's where most of the challenges come there. There are technical challenges around dealing with things that are not your native environment that you need to get a handle on. These are very, very easy to overcome. All you need to do is wade through the documentation and understand it. not too hard. For some definition, not too hard. It is certainly predictable, easy, and you can do it. The way more interesting challenges are what I've called political challenges. Political is a catch-all word that basically means dealing with people. This is why this is a challenge. You have to deal with people. And as developers, you should be dealing with people a lot anyway. You should be quite good at dealing with people. If you're not very good at dealing with people and not very well at communicating and understanding other people in whatever role they're in and how they interact with you, you are not going to be a very good developer. So you will get good at dealing with people because all the good developers are good at dealing with people. Deployment introduces a whole new kettle of fish when it comes to dealing with people, and that's called the IT department. Because it's not you who manages that IBM mainframe or the IBM mini computer or that Windows server if you're lucky, it's someone else. And I deploy to traditional IT environments, which have traditional IT departments attached to them. And they like to have control. This is not the world of DevOps. The world of DevOps are doing cloud deployments, are doing chat ops, are doing the cool stuff. The IT department exists to have power. They control the budget. So the key thing about getting a great deployment into a traditional IT environment is to work with your IT department, or in my case, my client's IT department. My client couldn't care less about the challenges I have getting the software I've written for them onto the computers that are controlled by the IT department. So what is acceptable? What is the IT department happy to let me do? Do they need some control in this? Do they want to have the final button to press? It depends. Generally, we can build a fairly good rapport and we can make everyone's life easier. Sometimes you end up with some really weird situations. About 6 years ago now, when I first started with one of my clients, the IT department insisted that we sent them a CD with a copy of the source code for every deploy we did. Even after we had automated it, we still had to send them a CD of what we had just put on their server. Just an invoice, just add some money to the invoice. If that's what they wanted, that's what we did. It didn't matter to us. We can get IT to do things for us. We can get IT to be in control of things that we don't need to know. They can be quite beneficial to help them and get them involved in the system. And that's where change request documentation comes in. It is highly likely that if you have an IT department involved, the IT department has processes that were probably invented in the 80s, maybe the 90s, but a long while ago. And they will require change request documentation. And this is where you start to learn the benefits of automating your issues system and being able to have an API that allows you to pull out the list of changes that have gone into any given version of your code. Certainly things like PRs in GitHub make this trivial. If all your code is put into your main master branch or via your develop branch via a PR, you have an API call to get a list of all the changes that ever happened in your system. And if your PR process involves linking to your issue system, so that given a PR, you can work out exactly which issue was involved, you can get a complete change log with no effort whatsoever, just a few API calls away. And you now start having the list of things that are going to be deployed in the next release. And I've got at least 2 clients that require that list before I can run the deploy system. They need to know what is going into the next release before it goes in. And then they have to get all the business owners who are involved in any of those changes to sign off on it. Because there's this whole idea of collective responsibility or passing the blame, whichever way you would look at it. So again, automation makes that much easier. So yeah, a lot of things about people there. What I'm going to finish up on is talking through a couple of case studies of situations that I've had to do in the last 2 or 3 years, something like that, I think these are now. Case study 1, an internal system. The client self-hosted everything. They are a finance company. They believe that the cloud cannot be trusted. They are very, very keen to control everything. It's all within the company network. So this is a Windows box. It's IIS, it's SQL Server. It doesn't have access to the internet. Only runs internally. That was interesting. If you don't have access to the internet for your live server, how do you get the deployed code there? Because obviously I'm on the internet and my development is all done outside of their company network. So we ended up with a multi-script solution. And we had one script that tagged the code and built a tarball. And then the tarball was shipped to the UAT server via a VPN system, which fortunately we were able to script just about. The only downside from my point of view is it only works on Windows, so I have to run up a Windows machine to do this. Then, because we are not allowed access to the live server, once the UAT system is signed off, IT copy that tarball that I provided over to the live system, and then they run a deploy script on their live server to do the actual deployment itself. It's a pain, but it worked fairly well. It worked remarkably efficiently as long as we communicated in advance, so that everyone knew when this was happening, so that we had an IT person on standing by ready to do the actual work. From my point of view, it wasn't my problem. You know, we talked about that self-deploy thing, the whole idea that someone else can do the deploy. This is what this is. My job was to get it to UAT, and it was the customer's job to put it live. So although it was a manual process of actually going live, from my point of view, it was automated. It just had someone else do it work for me. From my point of view, the customer did a self-service deploy. As long as they used the tarball that I provided, and with that tarball I shipped an MD5 checksum so that they could actually validate it, we ended up with a fairly robust, relatively easy to run system. Mostly scripted, didn't need much work on their part. Their IT department's not quite ready for a build server. I think another year or so. We might have taught them into it. We're getting there. Problematic. Fun though. Very interesting to come up with a solution that involved a minimal amount of work by me, which was obviously one of the key drivers, from my point of view, for a good deployment system. Case study 2, my mini computer. This is an AS400. We call them mini computers. I don't know why, but that was the name that we used back in the old days. The box is about the same size as any other server. They're called mini computers. Self-hosted by the client again, because no one in their right mind would run one of these computers otherwise. We had some access to the internet this time. That made life much, much easier. Much, much easier. The biggest problem with there was that the IT department were very, very suspicious about opening any hole in their firewall. It required a lot of effort to persuade the IT department that it was worth opening holes in their firewall and that they weren't about to get overrun by gremlins every time they opened anything up. IBM series, it was a DB2 system, worked fairly well. They're very reliable. One of the nice things about these iSeries is that you can change the processors whilst the system is still running, which is quite neat. Not many people have that use case though. It's easier just to run multiple computers. We had CI tooling, which made life much, much easier. So everything was CI tooled. What we didn't have was the ability to automate it all because of political concerns. The company's dev team was very, very wary of automated systems, putting stuff live without a manual person involved. So what we did there was we had a checklist of things that they had to do, and they manually tagged for the creation of the release. So we gave them the manual process of you may tag the repository, because we thought we could trust their developers to do that. We wrote them a script to help them, but they manually tagged the creation for release, and then the CI system took over and automated through to deployment once they have manually tagged. So we could have had a completely automated system. It was built in, it would have worked. This is on a 1980s era computer, so the technology is never the problem. It's all about the people and processes. The dev team wanted a manual checkpoint that they controlled for deployment. So we gave it to them as early as we could in order to ensure that the rest of it was as predictable as we could make it. So manually tag and then deploy automatic from that point on. And that worked really, really well and has been a very successful solution. I've got one final thought, which comes from my friend Liz. Deployment is still the hardest part of programming. Sometimes you need to make decisions based on what you can support and maintain. So although we could do the whole ChatOps thing, because that is the cool stuff, it's not necessarily the right solution for any given project. So depending on what project you have, depending on the capabilities of the people, the requirements of your customer, where you are trying to deploy it to, those will be constraints on the final solution you end up with. There is not one size that fits all when it comes to a deployment system. So it is worth being aware of the choices you can make. And Lee wanted me to finish at 9, so thank you very much. And don't forget to go to Joined In, because I would like a free drink. Any questions? I love it when my talks are this clear.
What's the oldest thing you've deployed to?
What's the oldest thing?
Yeah.
In terms of the technology, it's probably IBM I, because they're early 80s products. Well, Linux isn't that much newer, to be fair. That's early 90s. Yeah, the IBM I's are fairly old, and the one we did fairly recently was a fairly old one, and they were due for a new one, but it hadn't arrived yet. So it was a really old computer because it had the UAT system on it as well as the live system. And when we went live, we had to turn off UAT because we ran out of processing power, which is not a good sign. About a week and a half, 2 weeks later after that, the new box turned up, which was a relief because that was so much more powerful. It's interesting because they're really good number crunchers, but their I/O certainly has improved over time. And clearly this bot's been in production for 10 years or something, which wasn't a problem until we started doing a lot more I/O with it. Now, oh, okay, that's why they've released those new versions since then. I've got some SQL Server 2000s still in production.
Pretty young.
Really? Doesn't feel like it. Have you tried using SQL Server 2000? It's horrible. SQL Server 2008 is a really nice database. From 2008 onwards, SQL Server is very nice to use. Mostly because that's the point where they introduced their version of limit. So you could actually select something that's not the first X amount out of the database without a sub-select that reverses everything, which is a horrible solution. About it, most of this stuff is not old. It's mostly the thinking that's old rather than the tech. Anything else?
Yeah, I was going to ask, if you're in that sort of middle ground of not using the third level tools but in the thing ant stuff,
Yeah.
how do you deal with cases where something in your set of thing scripts that maybe do 5 or 6 different targets, something hits an error in the process?
Carefully. The thing about thing scripts or make scripts or whatever they are is that people don't realize that they're programming, and they think they're just knocking these things out. And my deployment scripts, the ones I did recently were Thing because we needed PHP tooling on the final place. And that's got its own set of tests. And I think it's really easy to assume that because you're writing scripts, you don't need to test and you don't need to have the same rigor. And that's dangerous. The knack is to have a system that allows you to roll back and to do non-destructive things. Do non-destructive things before you get an error. So you can actually roll back. But that's not necessarily possible. But not impossible.
It's
the riskiest bit is database migrations. Everything else is fairly easy. Like, you're not going to overwrite files directly on your server, for instance. You're going to deploy to a different directory, and then you're going to switch a symlink, or you're going to do a hard link or something like that. You're not going to do a direct in place over. Oh, actually, maybe you do. You should never ever do a direct in place override because you can't roll it back. And the key thing is that when you get an error in your deployment, you must be able to do a rollback back to the state you were in, so that you can diagnose it offline. There's nothing more stressful than trying to diagnose a problem when it's on the live site and the live site is down. So by far, what you want to be able to do is roll back to where you were, work out what happened, and then fix it. And the code is easy because you got deployed to a different directory. So all you need to do is flick the symlink back to the old version. The risk is normally the database, because normally people write their up migration. Let's say you go change some columns. The naive way to do it is that you add the new columns, do the data migration, and then delete the old column in the same migration. So it looks like an atomic thing that happens. The database changed from this schema to this schema in one migration. The problem is that if you do that, you can't roll back. So if you're going to add or do anything that looks like a data transformation in your database schema, and to add new columns to replace old columns, get transform data, whatever it is, keep the old data and the old schema around for at least one and preferably 2 more releases. So you can always roll back. When you roll back the code, you still have the old data, or the data in the format, the structure, the schema, whatever, in the same format as it was expected. Because errors do happen. If you're halfway through your thing script or whatever, and you discover your network card dies. It does happen. Not often, but it does happen. And when that does happen, you need to be able to get back to where you were. So never ever destroy the rollback system. If you can, make the rollback system a script as well, so you can actually roll back really, really easily. And if it's not a script, make sure it is a written down checklist. The very, very last thing you want to be doing, again, because you're really, really stressed at this point, is to be thinking on the fly, how do I roll back? That's such a stressful situation to be in. I've only been in it once because I wrote the checklist the second time. It's horrible. It's actually a horrible situation to be in. The live server is down, the client's on the phone, you're losing money because it's an e-commerce website, and you're having to think, well, how do I get this back? Oh, I need to change that symlink, or what symlink do I need to change it back to? And that's quite a stressful process to be doing. So if you can avoid doing that by having a script that does it for you, or at least have a list of exactly step 1, step 2, step 3, for when the deployment goes wrong, that helps a lot. Generally, you only make the mistake once. Then you write a script up, because it's hard work at that point. Does that help?
Am I right to infer from what you just said that you recommend, like, if you're going to change the sort of details of a field, you can make it like an enum instead of a boolean or something. Yep. You'd suggest changing to a new field, leaving the old one there. Oh, so don't just.
I think you have to be very, very brave, and much braver than I am, to change a database schema without making it backwards compatible. I've seen people do it and have no problems, but I'm not one of those people.
Would you go as far as to make sure the new version also maintains the old field?
Oh, most definitely. So let's say you are changing from an integer field to an enum. No, you never do that. Let's assume you've got an enum and you're changing it to an integer field, because you've suddenly discovered that you add in lots more statuses and it's so expensive to add a new enum because limate, whatever it might be. Yeah, I would add my new field, add my new column. I would make the code write to both columns. I would deploy that. Then at some point else, I would remove the other column and take out the code that wrote to that column, when I was 100% convinced that I would never ever need to go backwards. If anyone disagrees with me, by the way, shout. If you've got better ways of doing this stuff, feel free. Anyone else? Cool. Well, thank you for your time. Let's go to the pub.